Welcome to NAIOP Solution Series program titled Essentials for Selecting Solar Systems. My name is Elizabeth Sherrod, and I will be your host. The Solution Series programs are available at no cost to NAIOP members. These mini-webinars run less than 30 minutes, and our goal is to provide you with some quick tips and insights, all types of positive strategies and tactics to help succeed in today's business environment. Is there a topic you would like to learn more about? Please send us an email to solutions@naiop.org to let us know what topics you would like to hear from in future programs. Next slide. NAIOP has produced the popular Solution Series programs for almost 3 years. Did you miss one of our informative topics? The archives of these programs are available to NAIOP members at no cost through the on-demand bookstore. Examples of past programs are listed on the current slide. Our topics cover finance, niche development, logistics, and more. Visit the NAIOP website at www.naiop.org/Solution Series for links to the archives. Next slide. And now, let's get on with our program. With us today is Aaron Binkley, Director of Sustainability Programs for ProLogis. Aaron's responsibilities include customer and investor education programs, energy efficiency and retrofit initiatives, as well as working closely with operations and development teams globally to further ProLogis sustainability efforts. Prior to ProLogis, Aaron was Director of Sustainability Programs for AMB Property Corporation. At AMB, Aaron was responsible for the development of 4 megawatts of rooftop solar projects and due diligence for 60 megawatts. He was also responsible for customer advisory on renewable energy for new construction projects and existing buildings. Aaron is a registered architect, lead accredited professional, and member of the Real Estate Roundtable Sustainability Policy Advisory Committee. Aaron served on the U.S. Green Building Council, Warehouse and Distribution Center, Adaptation Working Group, revisions to the renewable energy credit. Welcome, Aaron. Thanks for being with us today. Next slide.
Thank you, Elizabeth. Today, I'm presenting an overview entitled Essentials for Selecting Solar Systems to help identify the right technologies for solar projects on commercial buildings. This webinar is based on the Solar Technology Reference Guide, which is available on the NAIOP Foundation website. The guide provides real estate decision makers with the information needed to evaluate the impact a solar project can have on the underlying building. This information can be used to make side-by-side comparisons, select and install the most appropriate solar technology for a given building. The Solar Technology Reference Guide provides recommendations such as best practices for building design to identify suitable building sites, understand design considerations, manage costs, construction risks, and roof impacts, and to address local climate considerations and evaluate warranties. Information in the guide will prepare you to execute projects quickly, profitably, and without undesired structural or operational impacts. Let's begin by talking about a few basic terms used throughout the guide. Solar cells are the building blocks of electricity generation. These are small semiconducting wafers that are grouped together to make a solar module. A solar module is what we often refer to as a solar panel. This is a complete energy-generating device. Modules come in many shapes, sizes, and colors, and they're rated based on their wattage output. An assembly of solar modules plus any remaining equipment needed to create a functioning solar project is known as a solar array. All the other pieces and parts are referred to as the balance system, or BOS for short. The solar market has experienced 27-fold growth in the past decade, and it's continued to grow even throughout the recession. 2011 actually exceeded projections on the chart below and saw 1,800 megawatts of solar modules installed. The United States remains one of the world's largest solar markets, and regulations in many states make projects on commercial buildings attractive. While solar industry terminology is good to know, it has only limited value unless you understand which technologies will have the fewest impacts on your specific property. As this table shows, solar module composition in the left column can be used in a widely varying range of solar array configurations. These are listed in the top row. Rather than focus on the composition of the solar module, it is often more meaningful to focus on the array's method of attachment to the building, its weight, and any special installation needs that will affect the underlying building or the occupants of that building. There are 4 types of solar module systems covered in the guide. The most common are rack-mounted PV or photovoltaic module systems. These are the most common types of arrays. They're designed to accommodate a wide variety of module types. They're field assembled, which makes them very customizable. They can also make these systems more labor intensive to install, however. These systems generally, although not always, require ballast to weigh them down and resist wind forces. This increases the weight of the system. Rack-mounted systems can be installed on nearly any type and size of roof. The second system suitable for commercial buildings is the composite frame PV module system. These consist of a pre-assembled modular unit that can be installed quickly as a unit with few tools. These are less customizable than rack-mounted systems. They do install quickly and tend to need less ballast to hold them in place. There are a limited number of manufacturers of these products. These systems are optimized for large, unobstructed, and low-slope commercial roofs, such as warehouses and big box retail. Adhered building integrated PV module systems are often referred to as thin film arrays, even if the term is not precisely correct. These are the lightest weight solar products on the market. They adhere to the roof and therefore eliminate the need for ballast and racking. The support system is the roof itself in this case. Various versions of this system can be installed on membrane roofs, metal roofs, and even built-up asphalt roofs with proper preparation. A few roofing manufacturers even offer products with these solar modules pre-installed at the factory. The fourth category of solar arrays is structural building integrated PV module systems. These systems are fully integrated into the building itself, the curtain wall, an atrium roof, canopies, and carports. They're highly engineered solutions. Not surprisingly, these systems are generally the most expensive. They're installed permanently and become integral to the building. The aesthetic appearance of these systems can be carefully controlled because they are a part of the building. In many instances, more than one type of solar array may be suitable for a given building, but that doesn't mean that there aren't important trade-offs to consider. The guide provides a detailed comparison of the pros and cons of the 4 system types for commercial building applications. For example, the table shown here allows you to rank the attributes of each system to determine the one that will work best for you and your given project. Solar modules used in solar arrays can vary in both size and weight. With a few exceptions, modules are designed to be carried by 2 workers and to be compatible with most commercially available racking systems. The graphic shown here compares the relative size of a range of solar modules. The 3 on the left are common sizes used for rooftop applications. The large square module to their right must be craned in place and is a better fit for carport or ground mount applications. The tall, thin module to the far right is a flexible thin film product that gets bonded directly to the roof surface. As I previously mentioned, weight is often a driving factor in the ability of a building to safely support a solar installation. Few buildings were designed with solar in mind, and excessive added weight can lead to unwanted problems. A solar array's weight can vary from 1 pound per square foot to more than 9 pounds per square foot, depending on local conditions, wind zone, and system design. Adding a solar array to a building must be carefully planned to avoid affecting access to rooftop equipment and to avoid impeding roof maintenance and inspections. Up until now, we haven't mentioned solar panel efficiency, the amount of energy generated by a module. Efficiency varies based on module composition, system design, and geographic location where they're installed. Across all products, the spread goes from about 5% on the low end to over 18% efficient on the high end. Efficiency ranges of the various module compositions do tend to overlap. For example, you can purchase 12% efficient modules with 3 distinct module compositions, even though the most efficient modules in each category can and do vary widely. This is illustrated in the table below. In practical terms, the more efficient the solar array, the less space it will take up on the roof for any given amount of output. An optimally designed and highly efficient array may require 1/2 the space of a less efficient technology. This is illustrated conceptually in the diagram on the right. In most cases, only 50% to at most 80% of a roof's area can be covered with solar modules. This is because setbacks, shadows, maintenance needs, and future flexibility to install HVAC and other rooftop equipment limits the space available for solar. You can design new buildings to support an efficient solar layout. This maximizes the roof area available for solar while also enhancing safety, flexibility, and ease of maintenance. Common mistakes include failing to co-locate rooftop equipment in areas that minimize shadows on the solar array, and not aligning skylights to allow direct paths of travel once the roof is covered with solar modules. Construction of a solar array can have significant impacts on the host building. The guide highlights key considerations that impact the speed and effort required for construction. Staging the site to minimize tenant disruption is critical, as is minimizing rooftop traffic to prevent excessive wear that could jeopardize roof warranties. Installing a new roof can reduce the impact of a solar array on the building. This is also an opportunity to specify a product that will withstand the added foot traffic during installation. Regardless of roof type or age, before and after inspections are necessary to avoid finger pointing if roof leaks or other problems are identified after the project is completed. The hum generated by the solar project inverter and transformer electrical equipment should also be considered when near residential neighborhoods or near regularly occupied tenant spaces. There are reasons to be optimistic about the future of solar on commercial buildings. Costs continue to decline and new technologies coming to market offer better performance. Experienced installers are faster and more cost competitive than ever. Even the solar industry shakeout due to the recent slow economy has a silver lining. It will ultimately result in stronger solar companies with better products and even lower costs. This webinar has provided an overview of the contents in the Solar Technology Reference Guide. The guide provides the commercial real estate industry with the information necessary to understand how to evaluate and select solar technologies. This information helps you minimize the impact a project has on the host building, while at the same time maximizing the benefits to the property owner. Download the Solar Technology Reference Guide today from the NAIOP Research website to learn how you can ensure your next solar project is a success.
Aaron, thanks for a great presentation and sharing your insights on the pros and cons of solar technology for the commercial property owner. Our next Solution Series program on the Southeastern Institute of Manufacturing and Technology will be available on March 6th. Watch your email for NAIOP Source, our corporate e-newsletter, for the program link. Thank you for listening to our session, and have a good day.